Hello, this is Brother Tony, and this is the first flipped lesson about static structures. And what you should have done before starting this is to read and take notes on learning activity number 1, pages 1 through 10. And that would be on Moodle. The objectives for this lesson, though, is to number 1, understand why bridges are static structures. 2, see how forces must be equal and opposite in a static structure. And 3, be able to calculate force in newtons. So let's begin. The rest of this quarter, we'll be talking about bridges, designing a bridge, analyzing a bridge, and doing some mathematical analysis. Now, one of the things about bridges is they're designed not to move, and that's called the static design. What we want to be able to do is provide and analyze these bridges statically to see when they would fail. So here's a little bit of background. What you'll see is a drawing here. So let's start out saying we just have a one-member bridge. This long piece is one member. Now, what you'll see in the future, on the left-hand side of that triangle, that's saying that's being pinned to the bank, meaning it would not move right here. That's solid. On the other side here, that's actually a roller, and that allows the bridge to move just slightly, and allows our analysis to be much easier. Now, the idea of a bridge is to say the sum of the force in the y direction means that it's 0. The sum of the forces in the x direction must equal 0. And the sum of the moments must equal 0. So meaning, if that's the y direction, that if a car goes over and the car has mass and gravity is pulling it down, the bridge must resist the downward motion and be able to stay upright. So the sum of the forces is 0. Same thing in the x direction. If something pushes against it, the bridge would push back. Sum of the forces in the x direction would be 0. And the sum of the moments. Now what a moment is, it's very equivalent to torque. It is some force acting at some distance. Torque is F times D. In our examples, we'll see that moment, the moment, is some sort of force times R. Okay, here we have a single member bridge. And this member is staying upright. It's not moving. Now, what's opposing it? On the earth, any place where there's mass, there's gravity. So in essence, gravity, the force of gravity is pulling down this member, trying to pull it into the earth. What opposes it? Because what we're saying here is in order for a bridge to stay upright, the sum of the forces must be 0. So we have a force going down, that's gravity. We must have something opposing it, equal but opposite direction. And what that is called is the normal force. This normal force opposes the force of gravity. And the normal force is from the component that makes up the bridge, the material, the steel, the wood, etc., that makes up that member right there. But if we go beyond that, if we take a look at the physics of it, the normal force is in physics what we call the electromagnetic force. Okay. When elements bond together, when elements create compounds, the electrons interact to bring this together and actually have a resistance to being broken apart. So when you sit down in a chair, when the chair is empty, that normal force, all that normal force is doing is reacting against gravity for the actual material of the chair. However, when you sit down in it, then the electromagnetic force also is strong enough, hopefully, to keep the chair at a static, as well as to take your weight. And it will do so until it gets overweighted, and then it collapses. So what I want you to remember from this slide is that the sum of the forces in the y direction especially, anything pulling down due to gravity, will be counteracted by the normal force going up. And the normal force, the physical term, the physics term for that is the electromagnetic force. When we do analysis of bridges, when we do analysis of static forces, or in physics, when we talk about force, what we're talking about is force equals mass times acceleration. And in this case, we will say, for us, force equals mass times g, the acceleration due to gravity. So in the metric system, mass is weighed in kilograms. Acceleration due to gravity on Earth now, g equals 9.8 meters per second squared. And what that per second squared is, as an object gets pulled towards the Earth in free fall without any friction, it will continue, the velocity will continue to increase. So now let's take a look at how this actually works. So right here on the left-hand side, we have a single structure with 10 kilograms on top of it. So the force would equal mg. The force of that 10 kilogram mass is 10 times 9.8. So force equals 98 meters per second squared times kilograms. So the kilograms comes from the mass. The meters over seconds squared comes from the acceleration due to gravity. And what we get is a nice little unit of measurement called newtons. So a newton is kilograms times meters over seconds squared. So the force is 98 newtons. So now you have a 98 newton force going down through that beam. Now you know about the normal force. The normal force is pushing up in an equal and opposite direction. So if we say, in this case, that the y direction going up is positive, what we have here is we have negative 98 newtons. So 98 newtons going down to the Earth. So the up direction is the normal force exerts 98 newtons equally and opposite on that mass. What does that mean? The structure never moves. So the only time it would move is if the external force is greater than the strength of the structure, and then it would crack or bend. Now let's go over here to the right side. Once again, we have a 10 kilogram mass on top of there, and that is 98 newtons. Don't let the newtons throw you, okay? Now that we're using math as a tool, we will use units as well. But just know it's a unit of measurement for force. Now, pretend that you have these two structures are equal and they equally distribute the weight of that 10 kilograms. Now you have 10 kilograms going down, negative direction, negative 98 newtons. Now, right here, equal but opposite, since the force is distributed equally, you have 49 newtons on one member and 49 newtons on the other member, keeping that in perfect balance. Now you will notice that I do not say that there is 49 newtons on this member or 49 newtons on this member. What this means is we would have to use right angle trigonometry, and we would actually draw a triangle and we would see with the hypotenuse, using right angle trigonometry, how much force are on these two members. Okay, the purpose of a bridge is to transport something across a bridge. So there's going to be a load on it at some point. Anything that's not part of the bridge we'd call an external load. And the loads will be distributed. The bridge is going to stay up. The loads will be distributed and be counteracted either due to the tension or the compression of the members of the bridge. So on the left-hand side, what you have here is an example of compression. So I have my weight right there, and I have two members, one on the left, one on the right, and the load is pushing down with gravity. The members are actually compressing. They're being squished together, but they have enough normal force that by compressing, it resists the load going down and keeps it in equilibrium. Now looking over here on the right-hand side, we would have this member on the left, this member on the right, with tension. The load is trying to pull the two members apart. The normal force keeps it in equilibrium, but there is tension on those two members. And what we're going to see is when we do the analysis is we'll have one type of load, compression or tension, be the positive, and the other one be the negative. Thank you for your attention during this short video. Now when you come in for the class, there's going to be a short quiz, and from this video you should be able to answer what are the three forces that the sum of the forces have to be equal to zero in order to have that bridge being stable. What is the name of the physical force that resists a load? And it's not that we call it the normal force, but there's the physical definition, the physics term for it. If I give you a load and a couple of members, you'll be able to draw the reactions on those members. Then also to be able to tell if a member or members is under tension or compression. That's what you should have gotten out of this video. If you didn't, please go and review it. Also from the reading, I'm going to quiz you on some definitional terms. So any of those in black or bold, you should be prepared to answer. Okay, see you at next class.